All right, so what did we learn? What's a vector?
Force of magnitude.
It has both magnitude and direction. So vectors are typically written like so, using little arrows. So I might call this the vector U. U with a little arrow on top of it like so. What do I mean when I say it has magnitude? What's magnitude? Length. Correct. He kept saying words, eventually he hit the right thing. The magnitude of a vector is its length. How would I find the length of that vector? You what? Draw a triangle and use the Pythagorean theorem. All right, so normally, let's give this vector a name. This vector. To write vectors, we write them using little less than and greater than signs like this. So this vector is maybe, I don't know, it looks like maybe it's 3 over and 5 up. That would be the vector 3, 5. Its magnitude would be its length. And we use that symbol, just like we did dealing with complex numbers. We use the same symbol for magnitude. Its magnitude would be the square root of 3 squared plus 5 squared, which would be square root of 34. So there's this magnitude. And what do we mean by direction? The angle. All right, so the direction is the angle. How would we find that angle? Tangent. Tangent of the angle theta would be 5 over 3. So theta would be tangent inverse of 5/3. And that's not one of the ones we've memorized. We could, of course, use the calculator to get a decimal approximation for that. All right, so it asks us, given the vector u is -2, 3, and the vector v is 3, 4, sketch each of the following. U and v. All right, so where's u? Yeah, those are little arrows over the top, yep, to make it look like a vector. So where's u? -2, 3 is where? Left 2, up 3. And then you draw it as a vector. So there's u. What's that? Yeah, the tip of the arrow goes at the terminal point. That point's called the terminal point, correct. And where's vector v? 3, 4, so 1, 2, 3, 1, 2, 3. Lost my count on the way up. 1, 2, 3, right there. So there's vector v. Okay. How about 2u? Well, it's a multiple of 2. Correct. All this does, multiplying by 2, is it simply makes the vector twice as long. It changes the magnitude. So the vector 2u would be the vector -4, 6. So it's just going to be twice as long. So 2u would look like that. All right, how about -v? -3, -4. So multiplying by a negative number does what? Changes its direction, correct. multiplying by, because this is a 1, it doesn't change the magnitude, but because it's negative, it changes the direction. So it would be that vector, negative v. All right. How about the vector u plus the vector v? How do you think you add two vectors? Give you a hint, it's very, very easy. You add the x's and you add the y's. That's right. So it would be 1, 7. So 1, 7, 1. It would be this vector. That would be u plus v. Geometrically, here's what happens. If I draw the vector v first, and then I draw u starting from right here, it looks like that. So geometrically, the vector v plus the vector u gives you a triangle. So v plus u looks like. Finally, how about u minus v? Well, same deal, right? You subtract the coordinates. So it's going to be negative 2 minus 3, that's negative 5. 3 minus 4 is negative 1. So negative 5, negative 1 would be right there. That would be u minus v. Questions on that? All right, so far I like vectors. They seem easy. So far. Express the vector PQ in component form, where P is 5, 3, and Q is 1, comma, negative 1. There's a comma missing right there. Basically, what they're telling you in this problem is you have a vector which starts at 5, 3, and it ends at 1, negative 1. So here's your vector. Looks like that. To write it in component form means we want to take this same vector and we want to have it start at the origin, be parallel, and have exactly the same length. That's what component form means. Component form means start at the origin, be parallel to the original vector, and be exactly the same length. How do you do that? Okay. And then slope, good stuff. Or we just do a translation. So, what did I have to do? I had to take this point and move it how? I needed to move it 5 to the left and 3 down. So I also need to take this point and move it 5 to the left and 3 down. So if I move this 5 to the left, where's it going to end? Negative 4, negative 4. I go 5 to the left and 3 down. So yeah, all you really do is you translate it. So in other words, to put it in component form, you take where it ends and you subtract where it began. So I take 1 minus 5, negative 1 minus 3. So in component form, this is the vector negative 4 and negative 4. So all that stuff you were saying, find the length, find the slope, all good stuff. A lot harder than you really needed to do though. Okay? I take end minus beginning, 1 minus 5, minus 1, minus 3, end minus beginning. Yep. All right, number 3. Write the following vector in terms of I and j. What are I and j? Anybody know? In this case, I is a vector, so it does not stand for imaginary. It's not the imaginary I that we used before. I is a vector. Anybody know what the vector I is? It can't be a 1. Vector's got to have a length and a direction. I is the vector 1, 0. So it has length 1 and angle of 0 because it's straight to the right. J, on the other hand, is the vector 0, 1. So it also has length 1, but its angle is 90 degrees, or pi over 2 radians. You weren't. But sometimes people know it. That's why I asked, does anybody know? Nobody knew, that's okay. So I'll tell you what they are. So, the vector -2, 10. To write that in terms of I and j, I controls your left and right, j controls your up and down. So this vector is the vector -2i plus 10j. It has to go 2 down, so that's 2 i's, and 10 up, that's 10 j's. How about the vector 0, -4? How would you write that using i's and j's? That would just be -4j, because that one doesn't need to go left and right at all, does it? So this would just be -4j. All right. Determine. What's that symbol? Not absolute value. Looks like absolute value, but when we deal with vectors, it doesn't mean absolute value. Not direction. Magnitude. That symbol means magnitude, which means the length. So find the length of u, the length of v, and the length of u plus v. How do I find the length of u? Correct. It's our magnitude formula. So I do square root of -2 squared plus 3 squared. So that's the square root of 13. Length of v is square root of 1 squared plus -2 squared, square root of 5. And then how about the length of u plus v? What would I have to do first? Find each individual. No, not find each individually. Add them first. What is u plus v? How do I add two vectors written this way? It's as easy as you think. Add the i's and add the j's. That's right. So u plus v is the vector -i plus j. So its magnitude is square root of 2. To add u plus v, I add the i's, so that gives me a -1i. I add the j's, that gives me a 1j. So to find the magnitude, I take the square root of -1. I'm sorry, I take -1 and I square it. I take 1 and I square it, and then I square root that whole thing. Write the following vectors in terms of I and j, where the length of u is 40 and it has angle 30 degrees. Alright, so I'm going to draw a picture here. Here's my vector. The length of this vector is 40. And this angle right here is 30 degrees. How am I going to find the I and the J? I could do law of sines, but that's too hard. There's a better way. Not the Pythagorean theorem, but you're close. Not the Pythagorean identity. It has nothing to do with Pythagorean. When do we use law of sines? When we don't have a right triangle. Do I have a right triangle here? I do have a right triangle. So this would be my I direction, and this would be my J direction. If I know this is 30 degrees and I know the hypotenuse is 40, how do I find I? Cosine. So do you remember when we did polar equations? We had x equals r cosine theta. This is exactly the same thing. The I component is going to be the magnitude times cosine theta. And how am I going to find the j component? Well, j is the y. How did we find y in polar form? We use the sine theta. So, well, it's not really easier, but it's really the same thing. So j is the magnitude of u sine theta. All right, so u in this case is, it's 40, that's the magnitude, times the cosine of 30 degrees. What's the cosine of 30 degrees? Square root of 3 over 2 times I, plus the magnitude, which is 40, times the sine of 30 degrees. What's the sine of 30 degrees? 1/2 j. In other words, it's 20 square root of 3i plus 20 j. All right, so for part B, u is going to be the magnitude. The magnitude is square root of 3. Where did I get 20 square root of 3? 40 divided by 2 is 20. I just reduced my fraction. So for part B, I'm going to have the magnitude, which is square root of 3, times the cosine of the angle, cosine of 300 degrees I, plus the magnitude, square root of 30, sine 300 degrees j. So that's square root of 3 times, what's the cosine of 300 degrees? Well, where is 300 degrees? Quadrant 1, 2, 3, 4. It's in quadrant 4, isn't it? Because it's just a little short of 360. What's the reference angle for 300 degrees? 60. So what's the cosine of 60? 1/2. Plus square root of 3. What's the sine of 300 degrees? Negative root 3 over 2. Because I'm in quadrant 4. Reference angle is 60. So negative root 3 over 2 j. So final answer, I would write it as square root of 3 over 2i plus minus, what's square root of 3 times square root of 3? So that would be 3/2 j. Questions on that? Was that? No? Not right? Oh. I'll give you a second to finish writing. mostly. Still writing, so I guess not. Trying to wait patiently. Not easy. Flipping it over. Determine the magnitude and direction of u equals the vector -4, 3. Magnitude, we've done this a bunch of times already. How do we find magnitude? -4 squared plus 3 squared, and then do a square root. So that's square root of 25, which is 5. Then how do I find the direction? Tangent. Tangent of theta is y over x. So it's 3 over -4. I grab my calculator. Do I want my answer in degrees or radians? It doesn't matter. If you're doing your homework on WebAssign, follow the directions. Sometimes it asks for degrees, sometimes it asks for radians. Which one do you want me to use? Degrees sounds good today? Okay. So I'm going to have tangent inverse of 3 over -4. Calculator tells me -36.9 degrees. But I'm not happy with that answer. I'm not happy with that answer. It's in the wrong quadrant, all right? So it's giving me an angle here, -36.9 degrees. However, this vector is up here, isn't it? The vector looks like that. So how do I get the right angle? The correct angle, not a right angle, not a 90 degree. How do I get the correct angle? I have to add 180. So my angle theta should be 143.1 degrees. So be careful of that. Don't just blindly take the answer that you get from your calculator. You got to check your quadrants, make sure you're in the right quadrant. All right, we have time to do number 7. We'll do 8, 9, and 10 on Friday. A jet is flying in the direction of north 20 degrees east with a speed of 500 miles per hour. Determine the north and east components of the velocity. All right, so in a picture, the jet's going this way, and it tells us this angle right up here is 20 degrees. Remember, that's how pilots measure things. Pilots measure their angle from due north or due south. So north 20 degrees east means 20 degrees east of due north. What angle would we usually use? We would use this angle, 70 degrees here. 70 degrees. So how do I determine the north and the east components? Well, north is, so we don't usually call it the north component in math, we usually call that J. And east is left and right, so that's usually I. So east is the I component. How do we find the I component? I is just to the right, left and right. So to find the I component, we use the magnitude, which is 500. And then is it sine or cosine? Cosine, because cosine uses the adjacent and the hypotenuse. So it's 500 cosine 70 degrees. And then north is the j component. So how do I find the j component? That's the magnitude times sine of 70 degrees. All right, so you could grab your calculator and get decimal approximations for those, and that would be good. Questions on that?